All right, the question came up on number 8. Before I do number 8, you guys all know how to do these here. Yeah. What do I do here to both sides to solve? Square, not square root, square. When you square, you don't plus or minus, you just square. Here, when I, can I add the 9 or do I have to square both sides first? Square. Now when you square both sides, you have to remember, can I just put squares like this? No, I have to do a what? A quantity squared. And what does this become? Or how do I work this out? FOIL, good job. And I'm going to stop there. Equals 5x minus 9. So you would FOIL, subtract the 5x, add the 9, and then factor and solve. All right. Questions? No questions on 5, 6, so go straight to 7. Are you guys okay? Or questions on anything here before 5? Okay. Select whether each equation has no real solution, one real solution, or infinitely many real solutions. Oh, sorry. 5. 5 is similar to, I don't know which practice it was, but it was one we did. It was like, I think in maybe the first or second packet. Please put your phones away. Where we talked about if they are the same bases, what can you do with the exponents? Add them. So it's 3 raised to the 4/5 plus 3 over x. Do you agree? Equals 3 to what power? 7 over 5. Because the bases are the same and there's exactly 1 on each side, we can drop the bases and set the exponents equal to each other. And that is my new equation. Now some of you guys can do that in your head. You can just look and figure out what x is. Can anybody do that? What is x? 5. X must be 5, so that 4/5 plus 3/5 is 7/5. Do we agree? If you can't do that in your head, then you subtract the 4/5 and cross multiply. X equals 5. Are we good? Number 2. Number 2, because of the way it's set up, you are allowed to cross multiply, but you don't have to. The way we did it in class when we weren't allowed to cross multiply is we multiplied both sides by the common denominator. What's the common denominator? And I'm going to pause here. Does anybody remember what we did before we even multiplied? There was something I did from the very beginning. Because it was a fraction and there were variables in the denominator, we found our restrictions first. What 2 things can x not equal? 4 and 0. And that was only so that when we were done solving, if either one of these are solutions, do I write it? No, that, what would they call it? Started with an E, EX. Something solutions, extraneous solutions. All right. So, what reduces here? X minus 4. This was Unit 2 first semester. X equals what reduces here? X, and what do I do with the 3? 3x minus 12, and then you solve. Yes? Yes. Yeah, you can. I only showed you this way just in case if there were multiple fractions, then you couldn't cross multiply. But on this one, yes. X times 1 is x, and 3 times x minus 4 is a 3x minus 12. And then solve. I don't need to go further, right? You guys can finish it from there? Yes?
On number 6, the first problem that it gives you, why is it no solution?
Good question. Let me talk about that one there. We did these in a particular unit as well. It was Unit 2. We talked about it then. All right, if I was solving this, what would I do to both sides? Square root of x equals -2. What would I do next to both sides? Square, square, and x equals 4. That's one real solution, but the answer key says no real solutions. Why is that?
Because when you square root,
When what? When you check, which we should do, when you check, is this, what's the square root of 4? And is 2 plus 2 equal to 0? No, no. So yes, you do have to, remember, when we did this unit, it was the square roots one were the ones that we checked our answers at the end. How else can you tell right here before I squared both sides? Right here before I squared both sides, can anybody tell me how I could tell right there that there's no solution? Because the square root can't, what? No, the square root of no number is ever going to equal -2, right? Right, right. And even when it's imaginary, it wouldn't equal -2. There would be some i's in there,
Oh, yeah.
right? So the square root of no real number is ever going to equal a negative number, right? So no real solution. Does that make sense? All right.
How do you do the next step?
What was that?
How do you find out if you don't want it?
You solve. You go through. Well, first off, you would find your restrictions. So for this one, what can x not equal? 0 and negative what? And then do you want to cross multiply? 10x plus 10 times x, 10 plus times 20 is 200 equals 20x. You don't have to solve this all the way through to see how many solutions are you going to end up with. Actually, I would suggest you do, just in case, subtract 200 equals what? Just so that you can check with your extraneous solution. Divide, what does x equal? And does that conflict with any of our extraneous solutions? So how many solutions? 1. And then you would do the same thing with this one. X cannot equal 0. X cannot equal negative. For water? Okay. Oh, okay, thank you. X cannot equal 0 or -1. Got it? All right. Back side, gentlemen, please stop. Questions from this side? Was there still the number 8?
Yeah, the second.
The second one?
Yeah.
Select whether each equation has no real, 1 real, 2 real, or infinitely many reals. So this one here?
Yeah.
Sorry.
All right. I heard somebody whisper it. What was it? Cross multiply. So what is 4x times 9? 36x equals, what's 12 times that? 36x is right. What does that mean? They equal each other, so what? Infinitely many. Right? No matter what x is, if I multiply to the same exact number, there's going to be infinitely many solutions. Do you agree? Or you could divide by 36 first. And x equals x, which is always going to be true, so infinitely many solutions. Got it? All right, any others? Or do you want to just continue working?
Can you do 10, please?
Number 10? Okay. Was there another one?
Number 6 on the
6 on the next one? All right, so let me do 10 first. A student solved this in 4 steps as shown. Which statement is an accurate interpretation of the student's work? All right, so let's check the student's work. The first thing the kid did was -1 and -1. Is that correct? We got -1 on this side. The next thing he did was what to both sides? Squared both sides. And when I square a square root, they undo each other. And what's -1 times -1? 1. And the next thing it looks like they did is move the 3 over and got 4. Were there any mistakes in the student's work? No. So the correct solution is x equals 4. The student made an error. No. Student made an error. No. X equals 4 is a solution to the equation in step 2, but not to the original equation. Okay, so the student made no mistakes. So does that mean x is the solution? I'm sorry, does that mean 4 is the solution? Why not? What did we say about square root problems? What do? You check them, and did we check it yet? Okay, so did the student make a mistake anywhere in his work? No. Does that mean it's 100% surety that this answer is going to work? No, like that one that we did earlier with the square roots, you do have to check. All right, 1 plus the square root of blank minus 3 equals 0. What do I plug in the blank? 4. What's 4 minus 3? What's the square root of 1? And is 1 plus 1 equal to 0? No. So it's kind of like the one we had earlier. So what is correct? Letter A, the correct solution is 4. B or C, did the kid make any error in his work? No. So letter D says x equals 4 is a solution to the equation in step 2. Oh, step 2, but not in the original equation. Is that true? Yeah. And where does it count? Where does it have to work? In step 2 or the original? So what would we say if we were solving this? Would we say x equals 4 or no real solution? No real solution. Got it? All right, I'm flipping over to worksheet, to practice 9, was it? Yeah. Practice 9, what number? Number 6. Evaluate the claim as true or false for each set of numbers. Claim. All members of the set are solutions for W in the given inequality. Blah, 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 blah. -1, 0, 1, 2, all positive real numbers, all negative real numbers, yada, yada. What I would do is solve and see and compare, or you can plug numbers in each case, but I'd rather just solve and then compare. So 20W minus what? 30W minus what? 20 is greater than or equal to 4W minus 6. All right, I have like terms. 20W minus 30W is what? Louder? Negative 10W minus 20 greater than or equal to 4W minus 6. I want to get the W's to the left side, even if it's negative, because I can divide it out later. What do I subtract? And at the same time, what can I add? The 20. All right. 6, what is that? Negative, not 6. Negative what? 14W is greater than or equal to negative 6 plus 20 is what? And then I want to get W by itself, so what do I divide by? Oh, good. I heard a few people say when you divide by a negative, what happens to the inequality? Switches. W is less than or equal to 1 or negative 1. Okay, so what set of numbers are less than or equal to negative 1? What would it be? Negative 1, negative 2, negative 3, negative 4, and so forth? Yes or no? Yes. All right, so all negative real numbers. All negative real numbers. Can you guys check? Is it true? It does say yes? For 6 part 1. False. Why is it false? Because that's what I was thinking. You guys scared me when you said true. Why is it false? Is negative 1/2 a real number? Is negative 1/2 less than or equal to negative 1? No. So are all negative real numbers solutions? No. Negative 1/2, negative 1/3, all of those numbers that are in between 0 and negative 1 are not solutions, but they are negative real numbers, so that would be false. Does that make sense?
Yep.
All right. If it helps, do a number line. 0, I'm going to put 1, and negative 1. It's here and all of this. But do you agree there's an infinite amount of negative numbers right in between 0 and negative 1? Yes or no?
Yeah.
Right, so it's not all of them. What about negative 1, 0, 1, and 2? True or false? False. Negative 3, negative 2, negative 1. Is that in the shaded region? Oh, I marked the wrong one. All positive real numbers. False. -1. True. Make sense? And what number was this? All right. Any others from this same section? This one here? Solve the equation for x. Oh, that's a good one. It's been a while since you've talked about this one. I know you don't do this in Math 2, so you either learned it in Math 1 or Math 3. Or what? This one right here? Is this the one you wanted? Yeah. Number 11, it just got cut off. Solve the equation for x. What would I like to do? In order to solve for x, what would I do here first? Okay, you gave me what I should do, which is correct, but what would I like to do first is I would like to combine these. Do you agree? But since I can't combine them, Leonard, what did you say to do? Factor out an x. So 6 plus c equals 11. And I'm solving for x, so what do I divide both sides by? Now, if I'm trying to get x by itself, I'm going to divide by 6 plus c. And that there is your answer. X equals 11 over 6 plus c. This one?
Yeah.
Find b when x equals 1/4. There's different ways of doing it. Since it says find b, I can get b by itself first and then plug in x, or plug in x as it is and then solve. It's totally up to you guys. Do you want to just plug x in and solve, or get b by itself first and then solve? Plug it in. b times 1/4, because that's x, equals 20. I'm trying to get b by itself, so I would divide, I'm not going to, but I would divide both sides by what if I'm getting b by itself? 1/4, but I don't like dividing by a fraction, so I multiply by the what? Reciprocal, which is 4 over 1, or 4. Gone and gone. What does b equal? What does b equal? 80. And that's the same thing you would do over here as well. You either plug it in or solve for b first and then plug it in. All right, any others? We're good? Has anybody looked at 10 yet, or you haven't gotten there yet? Do you guys want to take a quick glance at that one?
Yeah.
And see, it's all review for Math 1 with all your linear graphing and exponential graphing. Oh, and Math 3. You guys did that a lot in Math 3 as well.
Oh, have to do this shading,
It looks like a lot of number 10, but it's just because the graphs are so big and spread out. But yes, they're shading as well. Yes. All right, we're done.